Here, rate of flow of heat in conducting material is Ka delta theta by L. So this is heat current. I is equal to Ka by L. So this because of temperature difference heat flows. This L by Ka is thermal resistance. So here coefficient of thermal conductivity Q here ml square T power minus T by T delta theta temperature here so coefficient of thermal conductivity dimensional formula m L T power minus 3 K power minus 1. Here it is L by K here is ml T power minus 3 area is so m power minus 1 T power minus T cube K power. So here it is not minus 1, it is plus 1. So A map to G. It is K power. Energy stored in an inductor. So dimensional formula of inductance will be energy dimensional formula current here that is ml square T power minus 2 A power. Here current some books instead of A they write I, that is the B maps to G. Magnetic induction here F equal to BIL. B here is by IL mL's T power minus 2 by M I power minus 1 T power minus 2. M I power minus 2 T power minus 2, that is C maps to H. Electric potential work done in bringing unit charge. Charge here is current into time. So ml square T power minus 3 I power minus 1. That is D maps to F. So final answer is a stone is projected with a velocity 10 root 2. Average velocity during its time. Whenever they ask average velocity, so net displacement by time. Average velocity is equal to net displacement by net displacement is nothing but range. Time is time of flight. 2u sine theta. Range here is square sine 2 theta by g, 2u sine theta by g. Sine 2 theta is by 2 sine, which is u cos 10 root 2 cos 45, that is 10 meter per second. A hunter fires a gun from the boat, so mass of bullet 35 grams. So let us use small letters, which is 35 by 1000 kg. The velocity of the bullet is 320 meters per second, fired at an angle 60 degrees. Mass of the hunter and boat is 70 kg. So the recoil velocity of the boat. This you take it as big mass. So here hunter plus boat is one system. There is no external force. Momentum is conserved. That is m into v plus mass of the bullet into v in horizontal direction. That is m here is 70. Recoil velocity, mass of the bullet 35 by 100 into in horizontal direction, its velocity 320 cos 60 is equal to initial momentum is 160. 70 V is equal to minus 35 by 100 into 160. 35 2s V equal to minus 8 by 10. That is 35 by 100. 0.8 meter per second. Here it is 35 by 1000, so 0.08 meter per second. So recoil velocity means plus. Here, body of mass 60 kg standing on a platform of mass. This is platform 40 kg. Here one body whose mass is 60 kg placed on a smooth surface. He throws stone of mass 1 kg with a velocity 10 meter per second at an angle 45 degrees with respect to the ground. That means true velocity of the stone. The distance between the boy and the stone on the horizontal surface when stone lands. Here once he throws this here, boy plus platform is one system. So once he throws some object, there is no external force. It is a internal system. Once there is no external system, external force, no change in center of mass. Initially, suppose boy is here. This is a platform. Boy is here. So center of mass will be actually platform center of mass. Platform plus boy, center of mass will be here. Once he throws with some velocity, so obviously what happened, center of mass will shift towards right. To balance it, boat moves towards left. That is, platform moves towards left. So here, in the time when it reaches stone reaches the ground, that is 2u sine theta by g. U here is 10 sine 45 1 by root 2 seconds. In this time, platform with boy move towards left. That is, what is the with what velocity means, since momentum is conserved, there is no external force. So here 60 plus 100 into v. V is the velocity with which velocity system moves towards left, plus stone 10 for 10 horizontal direction, 10 cos 40. That means v here is minus 1 by 10 root. The minus indicates it moves towards left. So in this root 2 seconds, the distance traveled is into root 2. That is, 1 minus only indicates moves towards left. So here, stone in this direction, how much it traveled, its range, u square sine 2 theta page. U square here is 100, 2 into 45, 90, 10. Towards right, it travels, the stone travels 10 meters. Boat travels zero point 0.1 meters. So the distance between boy and the stone becomes 10.1 meters. A vertical spring with force constant K fixed on a table, a ball of mass M at a height h above this is free end, at a h free spring falls vertically downwards, and so that spring is compressed by D. So here work done by a gravity is equal to mgh plus. So work done on the spring is equal to half kd square. Right. So the net work done on the ball will be mg into h plus d minus half kd square. Here, if a ball is thrown normally onto the big large surface, and before striking its velocity v, it rises with a velocity. Now he says ball strikes frictionless horizontal plane, making an angle theta with the normal. So in this direction, its velocity is after hitting it rises with v cos theta. So with v cos theta velocity, sorry, v cos theta is the direction. Sorry. If it is projected at an angle theta with the normal, so it hits normally the surface with v cos theta velocity. After hitting, it rises with ev cos theta, and the time taken for particle will again to strike the surface is 2t, that is 2 ev cos theta by 2u by g. A block of mass 10 kg is pushed by force F on a horizontal rough plane, moves with an acceleration 5 meters per second. Rough surface means there is a frictional force. That frictional force is mu s into n. Here normal reaction is mg. So F minus mu s into mg is m into 5. When the force is doubled, but frictional force there is no change. So it has an acceleration 18. Find the coefficient of friction. Subtract it. Minus F equal to minus 13M. Here if you substitute 13M minus mu S mg is 5M. So 13 minus 5, 8 equal to mu g. Mu here is 8 by 10, 0.8 meters. A body of mass 5 kg rests on a horizontal surface whose coefficient of friction is 0.2 is pulled through a distance 10 meters by a horizontal force 25. Find the kinetic. Initially it has velocity, so v square minus u square is 2as. That is v square. What we s is 10, 28. We have to find acceleration. Applied force is 25 newtons. Frictional force mu into normal reaction mg. That mg here is 5 into 10 is equal to 5a. This mu is given it as 0.2 into 5 into 10 is equal to is 15 equal to 5a. Acceleration is 3 meter per second. 20 into 3, 60. The kinetic energy acquired is half m v square. M is 5, v square is 60, so 150 joules. Third option is correct. Here, when air bubble moves up from the bottom of a lake, initially, a lake in the sense water, so when air bubble is here, force its own weight and upthrust acts. So F net will be upthrust minus force. Ma here is acceleration is upthrust minus this. So since it has an acceleration, so its velocity, initially it accelerates, so velocity increases. Once it accelerates, so velocity increases. So velocity increases. After that, once velocity increases, since bubble is moving in liquid, viscous force acts in opposite direction. Means when bubble reaches here, there is force upthrust, but viscous force, frictional force acts downward direction. Slowly, here now equation will be F net will be upthrust minus mg plus viscous force. Slowly, with respect to velocity, viscous force increases. So one stage comes when upthrust is equal to mg plus Fv. So F net becomes 0, acceleration becomes 0, velocity becomes constant. It is known as terminal velocity. So acceleration increases and becomes 0. B option is correct. Velocity increases, finally becomes constant. When force is applied on center of mass, it moves in a translatory motion. Suppose force is not applied, somewhere it is applied, not through center of mass, there will be a rotation also. Once it applies through the center of mass, it undergoes only translation, right? At the center of mass, there is always some mass particle. So, say if you consider a ring, center of mass will be at the center. There is no mass. So, second statement is wrong. First statement is correct. A body of mass m spherical body whose radius is r, rolling horizontally without slipping with a velocity v, then rolls up to a maximum height 3v square by 4. At this point P, total energy is converted to potential energy, that is mg into 3v square by 4. That is 3/4 mv square. Once it is rolling, it has translational and kinetic. Total energy is this, which is equal to 3/4 mv. So 1 plus k square by r square is 3 by 2. K square by r square is half. So that is possible for disk moment of inertia about an axis. So k square by r square will be half. That is per definite. Slope of an adiabatic curve, slope of isothermal. So it is PV graph. So delta take log p plus log v constant. Delta p by p plus delta v by v is 0. So delta p by delta v will be minus p by. If it is adiabatic, PV per gamma constant, gamma log v is log k. Once you differentiate it, minus gamma delta v. So delta p by delta v here is minus gamma p by v. So it is p by v, it is gamma p by v, gamma times. The escape velocity of a body on Earth's surface is this. Once it is projected, see if object is on the surface of the Earth of radius, it has a potential energy this, and it is given a velocity 3v. The energy, total energy it has is 3v square minus gmm by. When it reaches infinity, their potential energy is 0 because minus gmm by infinity. So kinetic energy, since he is throwing with a velocity more than v, because 3v, at infinity it has some velocity. That is at that point, let us say v1 square. G here is gm by r square. I will write here half m 9v square. Gm is gr square into this, which is half into m v1 square. G get r get cancelled. M9v square is 2gr minus mgr is half mv1 square. So 2 get cancelled. 8mgr equal to half mv1 square. So v1 square is 16gr. So v1 square will be 4. So v1 is 4 root gr. 2 root 2 times root of 2gr. 2 root 2 times escape velocity. So the potential energy of a particle which executing SHM, it generally at a mean position, potential energy is this, and kinetic energy is half k square. At mean potential energy 0, kinetic energy is immense. But he says at the mean position already it has some energy, 15 joule. And what is kinetic energy? Kinetic energy during one oscillation, that is average kinetic energy is 1 by 4 m omega square a square or k a square, right? But general kinetic energy is half k a square. Here he given average is 5 joules. At the mean position, maximum kinetic energy will be double the average. So total energy will be 15 plus 10. We have 25 joules is attached to a wire of length 0.3 meter long, which mass 10 kg. The area of cross section is given, the maximum angular velocity with which it can be rotated, so that wire cannot be broken. So here centrifugal force acts on this, which is tension will be towards it. If centrifugal force exceeds tension, then wire breaks. So the maximum tension it can bear is this. So here stress he given, that is force per unit area. Force is equal to area into stress. Stress is 4.8 into 10 power 7. Area is 10 power 6. It is 48 newtons. So maximum tension it can bear is this, which is mass 10 kg, length 0.3. Length becomes radius omega square. Omega square is 16. Omega will be 4 radian per second. Where two particles of equal masses have velocities, then velocity of center of mass will be m1 v1 bar plus m2 v2 bar by m1 plus m2. So m into v1 bar plus v2 bar by 2. So here it is 4i plus 4j by 2, 2i plus 2j. Acceleration ma1 bar plus ma2 bar by. So we get here a1 bar plus a2 bar by 2. So one particle acceleration is I plus j, other is at rest I plus j by 2. Here velocity is parallel to acceleration. That means it moves in a straight line. How can you say means this is ut plus half at square? For example, in x direction, if you consider x is equal to ut plus half, acceleration is half t square. Y also, here it is 2t plus half, acceleration in its half I plus half j, acceleration in y direction. From this particle moves in y equal to x in the straight line path. Here, if it is a soap bubble, so inside pressure is this outside. Inside pressure exceeds outside pressure. If it is in another soap bubble, so then it's of radius R2, we are inside, Here outside R2, Pi minus PO will be 40 by R. When they are in contact, just its radius R1, this contact surface will have a radius R. So the difference will be it's P1, let us say P2. P1 minus P2 will be 40 into 1 by R1 minus, which is same as effective pressure difference is 40 by R. So that 1 by R is 1 by R1 minus 1 by 3 minus it's 24. 4 minus 3. R will be 24 centimeters. Let us correct it. R1 R2 by R1 minus R2. Right. Here 1 liter of oxygen, volume 1 liter. Here another nitrogen, volume 2 liters. Pressure 1 atmosphere. Here pressure 0.5 atmosphere. Yet after mixing them, gas can occupy 2 liters gas or 3 liters gas that can be adjusted in 1 liter volume. So before mixing, that gas occupies 1 liter, another gas occupies 2 liter. Now both the gases, they have to be adjusted in 1 liter. So number of moles of gas will not change. N1 is RT1, N2 here is P2 V2 by RT2. So effective mole will be P V by RT because there is no change in temperature T1, T2 is T, then N becomes N1 plus P1, P, what he is asking, final pressure, PV equal to P1 V1 plus V2. So P1 here is 1 into 1 plus 2 into 0.5. Total volume, both the gases are adjusted in 1 liter. So final pressure will be 2 atmospheric pressure.